Right now, I'm going to take a little bit of time to explain how we're going to deal with the data that we collected in our burette titration lab. So first of all, I'm going to make up some data. I'm not going to go through all the trials that you guys went through. I'm just going to jump right to the average and say that I had an average of 8.0 milliliters of H2SO4 and an average volume of NaOH, let's say 17.5. Okay, if your numbers don't match that, don't worry about that. Okay, so the first thing we need is a balanced equation. First of all, we're going to be looking for the unknown concentration of H2SO4 in this problem. We know the volume of H2SO4 that we use, that would be 8 milliliters. We also know the volume of the sodium hydroxide. And the other piece of data that we know is that if you look at the procedure, you were using 0.16 molar sodium hydroxide. But we don't know the molarity of the H2SO4. So that's the whole point of doing one of these kinds of calculations. It's called a titration calculation, is to find an unknown concentration. In this case, it's going to be the sulfuric acid. Okay, but we need a balanced equation. So we're going to have H2SO4 reacting with NaOH. What kind of reaction is this going to be? So it's a neutralization reaction, and what are our products going to be? Okay, so you should have said H2O, and you should have said Na2SO4, sodium sulfate, and then to balance it, I'm just going to put a 2 in front of sodium and a 2 in front of water, and that's going to balance everything, balance hydrogen, oxygen, sodium, everything. Now, we're looking for concentration of sulfuric acid. So the definition of concentration, or molarity, is the number of moles over the number of liters, or moles per liter of a solution. So we already actually know how many liters of H2SO4 we used, or at least milliliters. It was 8, right? So we used 8 milliliters, and that number is going to go on the bottom of this little division problem we're going to do in the very end. But we don't know how many moles of H2SO4 we have, or how many moles we used. So that's where it's going to take a little bit of stoichiometry. Okay, so we're going to start with our milliliters of sodium hydroxide. Okay, and again, this is just my made-up data, but I said I had 17.5. You can put in your own number there and just put that over 1. Okay, and if you look down here, I've got the plan all set up for you. I did accidentally put an extra arrow in there, but we're going from milliliters of sodium hydroxide to liters, to moles of sodium hydroxide, and then to moles of H2SO4. Because again, remember, if we're looking for molarity, and we already know the liters of H2SO4, the only thing stopping us from getting the molarity is knowing how many moles of H2SO4 we used. And so that's what we're going to try to find right now. Okay, so first step, milliliters to liters. And I want you to set this up again right there on your paper using your data. Don't use 17.5 milliliters. Use your data. So that's 1 over 1,000. Okay, so now we've gone from here to here. And now we want to go to moles of NaOH. So liters has to cancel. Moles is going to go on the top. Where does this relationship come from? Or what is this relationship? Okay, so we should have said from our molarity, we have 0.16 moles per 1 liter. Okay, and then from moles of NaOH, I'm going to go to moles of H2SO4. And if I go back to my balanced equation, there's 1 of these for every 2 of those. And now I'm going to get my calculator out. You should do the same. You'll get a slightly different answer. Okay, so I got 0.0014 moles of H2SO4. And again, that is based on my volume that I basically just made up of, an average volume of NaOH of 17.5 milliliters needed to neutralize the acid and get that pink color change that we saw. So your number is going to be a little bit different, but I got 0.0014. And then the last step, very simply, it says once we know the moles, we're going to take moles. So again, I'm using my number, you should use yours. And we're going to divide it by the liters of H2SO4. Now remember, and I'll kind of do this off to the side, I had 8 milliliters, so of course to go to liters we're just going to divide by 1,000, right? So I should get 0.0080, oops, started to say milliliters, liters, there we go. And if I go ahead and do the division, okay, so I got 0.175, and that would be moles over liters, but of course we know that means molarity of H2SO4. So hopefully you were in that ballpark. That's, just using my made-up numbers, that's pretty close to what it should have been. But make sure you have that calculation done when you come to class.